Hi everyone, today we're going to do lesson 37b, day 2, continuing our work with absolute value inequalities. Our objective for today is to solve and graph absolute value inequalities. So let's do a quick review. As you might recall, the first thing we want to do is to isolate our absolute value. We want the stuff that's inside the absolute value bars all by itself on one side of the inequality. So first I'm going to send home those acquaintances. I'm going to add 11 to both sides. This will cancel out, and I'm left with 4 times the absolute value of x is greater than or equal to negative 1 plus 11 is 10. Next step, I'm going to divide both sides by 4. Now I'm left with the absolute value of x has to be greater than or equal to 10/4, which is 5/2. Now if you remember, when we have the greater than sign, we call it the great or, because we're going to make our two inequalities. In one, we're going to have our value, flipping this around, less than or equal to our negative 5/2. And in my other one, my x is going to be greater than or equal to my positive 5/2. Now I could make 2 and 3 and put it somewhere in between, but I'm just going to put a dot right here. It's going to be closed because it is or equal to. I'm going to put my 5/2 right here. And my numbers that are greater than that will go this direction. About here, I'm going to put my negative 5/2. And my numbers that are less than or equal to negative 5/2 will go this direction. It is an or inequality. Let's try another one. Bell always likes to ring when I'm in the middle of these. So this is a less than, if you recall that. So we're going to only end up with one inequality. First, I'm going to send home this 8. Let's subtract 8 from both sides. This cancels out, and I have the absolute value of 5 plus x over 3 is less than 7. Now I want to get rid of this 3 because it is not inside the absolute value bars. So I'm going to multiply both sides by 3. So now I have the absolute value of 5 plus x. I keep wanting to think that's 15 because of that absolute value bar. Is less than 21. Now, because this is a less than, I'm going to make one inequality. I'm going to put my negative value on the left, negative 21, my positive value on the right, my arrows pointing to the left, and my 5 plus x in the middle. Now only one step left. I still have to get this x by itself, so I'm going to subtract 5 from all parts. This is a positive 21. I don't know how that became negative. So now I have negative 26 is less than x is less than 16. So all of my numbers between negative 26, I'm going to put that here. Let's see if I can count by twos. 24, 22, 20, 18, 16, 14, 12, 10, 8, 4, 6, 4, 0. I don't think I can make it. I'm just going to put it somewhere here. I put my 16 here. But anything between 16 and 26 should be a solution. Let's grab an easy one. Let's grab 0. If I put a 0 in here, 0 divided by 3 is 0, plus 8 is 8. 8 is less than 15. Let's try another number that's out here more. I'm going to try, let's see, what's divisible by? I'm going to try 19. 19 plus 5 is 24. Divided by 3 is 8. 8 plus 8 is 16. That is not less than 15. So it seems like my numbers are probably right, that I made my graph the right direction. I could grab another one out here if I wanted to. Let's try 29, I think. Negative 29 plus 5 is negative 24. Divided by 3 is negative 24 divided by 3 is negative 8. The absolute value of negative 8 is 8 plus 8. That is not less than 15. So good chance I did it correctly. Sometimes good just to grab a couple numbers and test them out. Let's try another one. This is a great OR. So I'm going to have the OR graph. One will point to the right, one will point to the left. I'll make two inequalities. First thing we're going to do is subtract 5 from both sides. Now I have the absolute value of negative 2x plus 7 is greater than 9. Now I'm at the point where I'm going to make my two inequalities. Pull them out. I have negative 2x plus 7 is greater than, less than, sorry, I didn't turn it around, less than negative 9, or negative 2x plus 7 is greater than positive 9. I subtract 7 from both sides here. And I have negative 2x is less than negative 16. Divide both sides by negative 2. Don't forget to flip out. And I will have x is greater than positive 8. Over here, I'm going to subtract 7 from both sides. And I have negative 2x is greater than positive 2. Divide both sides by negative 2. Again, I'm going to have to flip my inequality since I divided by a negative number. And I will have x is less than negative 1. So at -1, I'm going to have an open circle. My numbers that are less than -1 go this direction. 0, 1, 2, 3, 4, 5, 6, 7, 8. At +8, I'm having an open circle. And it says x is greater than 8. See, I have that or inequality. They're pointed opposite directions. Wouldn't happen if you'd forgot to flip out, though. Remember, when you divide by a negative or multiply by a negative, you got to flip that inequality. Another example. I have quite a bit of stuff. I want to get this absolute value isolated. First, let's get rid of this 6 by adding 6 to both sides. This is a less than, so I'm going to end up with 1 inequality at the end. This cancels out. I have 9. And the absolute value of x minus 9 divided by 2 is less than or equal to 9. Now I'm going to get rid of the 2 by multiplying both sides by 2. This cancels out. And I end up with the absolute value of x minus 9 is less than or equal to 18. Now I'm going to make my compound inequality. Since it's an and, I'm only doing one. I'll put my negative value on the left, my positive value on the right, my x minus 9 in the middle, and my inequalities both point to the left. Now I only have one step left to solve this, and that is adding 9 to everything. So I have -9 is less than or equal to x. That's less than or equal to 18 plus 9 is 27. Well, I'm going to make this one pretty easy by counting by 9. So I'm going to make this -9 right here, +9, 18, and 27. At 27, I will have a closed circle. At -9, I will also have a closed circle. And the solutions to this inequality are all those numbers between -9 and 27, including -9 and 27. You could grab any of those and test them. Okay, so let's do a quick summary from yesterday. First, we're going to get that absolute value by itself. If it's a great or, pull out 2 and set up 2 inequalities. If it's a less than, leave the inequality together by adding the distance from 0. So -18 on one side, +18 on the other. Put the inequality in the middle. The x part in the middle, and then solve for it. And then don't forget to graph. That's it. Have a great day.